Hey guys, we're going to take a look at graphing transformations for trigonomic functions. Now to start off the video, we're going to only take a look at two kinds of graph transformations and two kinds of trig functions. Over here, I have the setup for two trig functions, sine and cosine. Now each function has a number in front of the whole trig function, which represents the amplitude, and then I have a number which represents b in front of x, which represents the change in period. All right, so if you guys don't recall, the amplitude represents the height of the graph from the midline either to the maximum point or to the minimum point. All right, and then for period represents the horizontal length of one complete cycle. Now, when I say the word cycle, I also mean the repetition of the pattern. Now, when we're asking what the period is for a trig function, we're trying to figure out at what degree or at what radian does the graph start to repeat the pattern. All right, so let's take a look at some few examples where we see the graph transformation based on having the number changing the amplitude or the period. All right. So for the first example, we have y equals to 2 times sine of x. So we see that we have 2 in front of sine of x. And over here, I have the graph for the parent function. All right. Earlier, if you guys remember, in the previous video, we already established the original graphs for sine of x and cosine of x. So we're going to see how this graph changes when we have the 2 in the front. And if we were to match the 2 with one of the graphing transformations, we see that 2 is in the same spot as a, which represents the amplitude. And remember, amplitude is the height of the graph. So that means that the height is going to go up by 2 from the original. All right, specifically the maximum and the minimum point. All right, so if we take a look at what the amplitude is for the original graph, we see that from the midline to the max, my amplitude is 1. So if the change of amplitude is dependent on the number on this 2 in the front, then that means it's going to go up by 2. All right, so for this maximum point, it's going to go up 2. And the same thing with the minimum point. For the minimum point, it was -1. So now with the change of amplitude, it's going to go down to -2. All right. So we see that for the maximum and the minimum, it increased the height by 2. All right. However, we have these 3 points which are on the midline, and the points that are on the midline the points that are on the midline, we can't really figure out what the amplitude is, since these points are on the midline. They're not a maximum or a minimum. So that means that the y values for my new graph, these values stay the same for my new graph. All right. So what I'm going to do is I'm going to connect the points from the maximum to the points that are on the midline. All right. So I'm going to make a curve in the middle and then connect it over here. And then for the minimum, and then the same thing for the minimum point, connect it to the points on the midline. All right. So the red represents my graph for y equal to 2 times sine of x. So just by looking at what the change was from the original to the new one, we see that the y values are increased by 2. So for the change of amplitude, we can say that we're multiplying each y value by the number in front of the trig function, which in this case is 2. So for each y value, I'm multiplying it by 2. All right. So we can also say for the graph transformation, with the amplitude, you're multiplying. So you're multiplying you're multiplying the y values by a. And I'm going to put a as red. All All right, so we're multiplying y values by a if we were to have a number a in front of the trig function. All right, so the x values stay the same, so it doesn't really change. And I'm going to write it in radians. All right, so we have 0, and if we were to multiply 0 times 2, we still get 0. All right, so we have 0, 0 times 2, that still becomes 0. All right, now we have the next radian, which is pi over 2, also known as 90 degrees. So we have pi over 2. All right, and then originally the y value was 1, and if I multiply it by 2, I get 2. All right, and then we move on to pi. So then pi, all right, so then pi for this, the output for pi is 0, and if I multiply it by 2, I still get 0. All right, and then we have 3 pi over 2. Originally, the y value was -1. If I multiply it by 2, it becomes -2. And then I have 2 pi, which is the period of both the parent function, sine of x, and the new graph, 2 times sine of x. So we have 2 pi, and the y value was 0. 0 times 2 is still 0. So the only y values that really changed were for pi over 2 and for 3 pi over 2. All right? So for this one, before I move on to the next problem, let's just describe some of the characteristics, specifically the midline, the amplitude, and the period. So for the midline, we see that the midline for both the original graph and the new graph is y equals to 0. So my midline for the new graph is y equals to 0. All right? And then we have the amplitude for my new graph. If we looked at the change of the amplitude, we see that the amplitude changed from 1 unit to 2 units. All right? So my amplitude for the new graph is 2 units. And then we have the period. So the period I'm going to put over here. All right, so for the period, let me move this up. We see that remember the period represents the horizontal length of one complete cycle, and we didn't really see a change in the horizontal length. We see that it is still 2 pi. All right, so these are the 3 characteristics for y equals to 2 times sine of x. All right. So let's take a look at the second example, which is y equals to cosine times 2 of x. Oh, y equals to cosine of 2 times x. All right, so now instead of having 2 in the front of the trig function, we have 2 in front of x. And if we were to match the 2 to one of the graphing transformation, we see that 2 is in the same spot as b. And b represents the change of the period. Now, for the period, for every function, if we were to have a number in front of x, we could use this formula. Period, which equals to 2 pi divided by b. Now, 2 pi is also known as 360. And if you guys recall, this graph that I have over here is a graph for the parent function cosine of x. So now we're going to see how this original graph changes with the change of the period. So that means that with the period, I'm going to have a new degree that the graph will start to repeat. Instead of it being 2 pi, we're going to have a new radian. All right? So let's actually go ahead and figure out the period first before we start graphing anything. All right, so I'm going to start off with the period. Now with the period, we have 2 pi, we have 2 pi, and then I'm going to divide that by the number that's in front of x, which is 2. So my b, in this case, is 2, all right? And if I divide those two numbers, 2 divided by 2, that becomes pi. So my new period is pi, and pi represents 180 degrees. So that means that at 180 degrees, the pattern is going to start to repeat on the graph. All right? So we see that the new period, the new radian is pi. All right. So with that being said, we see that the period for the original graph is 360 degrees. But the period for the new graphs for cosine of 2 of x is now 180 degrees. So we went from 360 degrees all the way to 180 degrees. So instead of the numbers getting bigger, instead of the numbers getting bigger like the previous problems, the number got smaller. All right? So that means that for each x values, the numbers are going to get smaller. All right? So to go from 360 to 180, we divide 360 by 2 to get 180. So that means that for the change of the periods, we're going to divide each x value by 2. All right? Okay. So let's go ahead and get started with figuring out the change of each x value. All right, so I have the original point starting off at 0, 1. And if I divide the 0 by 2, I still get 0. So I have 0, 1. So my y values are going to stay the same, but my x values are going to change. And then we have pi over 2 divided by 2. Now, if I'm dividing a fraction by a whole number or by another fraction, we do the keep, change, flip technique. We keep the same fraction, we change it to a multiplication, and we flip this number into 1/2. So that means that if I were to do this operation, I would end up with pi over 4. All right? So we have pi over 4, comma, 0. All right? So pi over 2 becomes pi over 4. Only the x values stay the same, but only the x value changes, but my y value stays the same. All right? And if you guys recall, pi over 4, if we were to turn it into a radian, it would become 45 degrees. All right? So now let's go ahead and move on to pi over 2 to pi. So I have pi, and I'm going to divide it by 2. Luckily, both of these are 2 whole numbers, so it just becomes pi over 2. All right? And pi over 2, comma, -1. All right? And then we have the next point, which is 3 pi over 2. And I divide that by 2. I do the keep, change, flip technique. And that becomes 3 pi over 4. All right? And if we were to turn this into a degree, that would become 135, which has a reference angle of 45 degrees. So we can say that for each degree, for cosine of 2x, we're going up by 45 degrees. And then we're left with 2 pi. So we have 2 pi, and I'm going to divide that by 2. So we have 2 divided by 2, which is easily 1. So that becomes just pi. And my y value is 1. So the only change that happened for example 2 were the x values. All right? So I'm going to go ahead and plot my new coordinates. Just for the x values, the y values stay the same. So let's go ahead and plot the new coordinates. So originally we have 0, 1. That stays at 0, 1. And then for my next point, we had pi over 2, 0. Now it becomes pi over 4, 0. So that's going to be over here. All right. So what I have over here listed out, I have it as 30, 45, 60, 90. Or in this case, as radians, we have pi over 6, pi over 4, pi over 3, and then pi over 2. So this over here, so the second grid for each one is going to be on the second one. Yeah, let me not say that. All right, so we have pi over 4, which in this case is also known as 45 degrees. All right, and then we have pi over 2. All right, and then we have the next point, which is pi over 2 comma negative 1. So pi over 2 comma negative 1. All right, and then we have 3 pi over 4. So this is 3 pi over 4 over here. So we have 3 pi over 4, or in this case is 135. 3 pi over 4 comma 0. And then we have pi comma 1. All right. So I'm going to make a curve in the middle. And then I'm going to connect my new points, which are the red points. All right. So we see that from the black graph to the red graph, the graph kind of shrunk horizontally. All right. So this would be my new graph for y equals the cosine of 2x. So for this example, since instead of ending at 360 degrees, we ended at 180 degrees. But what if I wanted to see how the graph looked like from 0 to 360 degrees? Well, what I can do is I can keep going by repeating the pattern. And if we got, what we can do is we can repeat the pattern as max, mid, min, mid, max. So then I'm going to continue the pattern. So we have max, and then we have mid, which is on the next 45-degree angle measurement. Mid, min. All right. Min on the 3 pi over 2. And then we have mid. All right. Oh, wait, let me see. All right. So then we have mid. And then we have max. All right. Now I'm going to connect the rest of the points. And this should be above here, because that was on negative 1.5. All right. So then we're continuing connecting the points. So this is what my graph looks like from 0 to 360 degrees. After 180, the graph starts to repeat the pattern. All right. And for one point to the next, we're going up by 45 degrees, or in this case, pi over 4. Okay, so now we're going to take a look at some examples where we have two transformations happening at one graph. All right, so in this third example, we have y equals to 1/2 times cosine of 3x. And if we take a look, we have the graph for the parent function, which is cosine of x. So now I want to see how the x and y coordinates are going to change with the 1/2 in front of the trig function and the 3 in front of x. All right, so let's go ahead and figure out what the transformations are. So if I were to match the 1/2 by either a or b, we see 1/2 is in the same spot as a, which is a change of amplitude. And if you guys recall in the first example, when we had the number in front of a trig function, we were to multiply the y values by a. So that means I'm going to multiply each y value by 1/2. And then we have the period, which is a number in front of x. So that means that the new period is going to be affected with this 3. And in the second example, when we had a number in front of x, we were to divide each x value by b. So I'm going to divide each x value by 3. And we're also going to have, instead of the period being 2 pi, it's going to be another radian. All right? So let's actually first figure out what the period is going to be. So I'm going to write down the period over here. All right? So with this period, I have 2 pi. And remember, the period for the graph of the parent function, cosine of x, is always 2 pi. Because after that, the graph starts to repeat the pattern. All right? So I have 2 pi divided by the number in front of x, which is 3. So I have 2 pi divided by 3. All right? So there's nothing to be simplified. 2 cannot go into 3. So my period is just going to be 2 pi over 3. All right? So that means that at 2 pi over 3, that's when the graph is going to start to repeat itself. All right, so now we have the new period, so we know that we're going to end in 2 pi over 3. All right, so let's go ahead and figure out my new x and y coordinates. So recall my x values, I divided by 3. My y value, I multiplied by half. All right, so let's go ahead and write out the original x and y coordinates for the original graph and then see how they're going to change. So I'm going to start off with 0, 1. All right, so actually let me just write it down. So we have 0, 1. So I have 0 divided by 3. I still get a 0. Then I have 1 times a half. I still end up with a half. It now becomes a half. All right, so I have 0, half. All right, so that's my new point. So then now I have pi over 2, 0. So I have pi over 2, and I divided by 3. So let me go ahead and write this point. We have pi over 2, 0. All right. So we have pi over 2, 0. And then we're going to take pi over 2 and divide it by 3. So this is where I have a fraction divided by a whole number. So this is where I'm going to have to do the keep, change, flip technique. I leave this as a fraction, I change it to a multiplication, and I flip this number as a fraction. So this 3 is going to become a 1/3. So now this is going to be pi over 2 multiplied by 1/3. And that gives me pi over 6. All right, and then we have 0. And if I were to multiply that by a half, I still end up with 0. So now we have pi over 6, 0. So I'm going to plot it somewhere in the graph. And on the graph, we don't really see pi over 6 in here, but each of the grid are the radians on the unit circle. All right. So this would be pi over 6, pi over 4, pi over 3, pi over 2, or in degrees it would be 30, 45, 60, 90, 120, 135, and so on. All right. So I'm going to plot my first point, which is pi over 6, which is over here, 0. So pi over 6, 0. All right. So now I'm going to move on to my third point. So my third point is going to be, my third point for the original is pi, -1. All right. So I'm going to take pi divided by 3. So I have a radian divided by 3. Luckily, there's no fraction, so I can just write it as pi over 3. All right. And then I have -1 multiplied by a half. I multiply these two numbers, and I end up with a -1/2. All right. So my third point is pi over 3, which would be over here, -1/2. So go down half. All right. I'm gonna write out the points after I get all my x and y coordinates. All right. So now we're moving on to the fourth point, which was 3 pi over 2. And I'm going to divide that by 3. All right, so I have 3 pi over 2, 0. So I'm going to divide 3 pi over 2 by 3. So yet again, we have a fraction divided by a whole number. So I'm going to do the keep, change, flip. I keep this, I change this to a multiplication, and this 3 becomes a 1/3. So I have 3 pi over 2 times 1/3. So we get 3 pi over 6. So we have 3 over 6. And if we were to simplify it, we would get 1/2, but we're doing the radians, so we have pi over 2. All right. So I'm going to write it as pi over 2. All right. So now we have 0. So I have 0 times 1, 0 times a half, which still becomes a 0. All right, so I have pi over 2, 0. And then I have then I'm almost done. So I'm going to move on to my fifth and final point. So originally we had 2 pi comma 1. So if I were to divide that by 3, I end up with 2 pi over 3. And what do you know? We have the same, we have the radian, that's the same as the period over here. So that means that after 2 pi over 3, the graph is going to start to repeat the pattern. And then I have 1. So over here, this is 2 pi comma 1. So I have 1 times a half. And multiplying these two numbers, I'm going to end up with a half. So now I have 2 pi over 3 comma half. So it's going to be over here. So now I have all my x and y, my new x and y coordinates from this graph. All right, I'm going to connect the points. So if we take a look, we see that from the original graph to the new graph, both the amplitude and the period shrunk. All right. So now that we already got the period, we're going to go ahead and try to figure out the midline and the amplitude. So I'm going to try to figure out what is the midline for my smaller graph. All right, so for my midline, we see that we're going from the max, which is a positive half, to a negative half. So if I were to, and with midline, we usually add those two. So if I were to add them, I end up with 0. And I don't really need to divide it by 2 because I still end up with 0. So my midline is going to be y equals to 0. So far, with all the examples we looked at, the midline really stayed the same, which is a good thing. All right, so then we have the period, then we have the amplitude. So let me write it down here. All right, so with the amplitude, that's when we take the y values from the maximum and the minimum points. So we have a half, we have 0.5 minus negative 0.5. We get 1, divide that by 2, I get a half. So my amplitude is going to be 0.5 units. All right, so my height from the midline to the max and the minimum points is 0.5 units, right? So my height, so it's kind of a little bit difficult to see with the new graph. Just because of the height is now, instead of it being 1, is now 0.5, all right? So in this example, we saw that both the height, the amplitude, and the period, the width, shrunk. So let's take a look at a few more examples where we still have a change in both the amplitude and the period, but we're going to see how this is going to be a little bit different than the previous example. All right, so we have y equals to 3 times sine of a half. All right. So if over here we have 3, which is in the same spot as the amplitude, so that means that my amplitude is going to be a 3. All right, and then with that, I'm going to multiply each y value by 3. And then we have a half that's going to affect the period. All right, so with that, I'm going to take each x value and divide that by a half. All right. Now, if you take a look, we're taking a whole number and dividing it by a half. So we're dividing fractions in this scenario. So instead of dividing fractions, what we can do is use a keep, change, flip technique to actually change the operation for this one. So instead of doing x divided by a half, first off, I keep the x, I change the division to multiplication, and I flip this half, and when you flip a half, it's going to become a 2. So instead of saying x times a half, it's now going to become x times 2. All right, so I'm going to go ahead and change this into, I'm going to write it on the top over here. We have x multiplied by 2. So that's what I'm going to use instead. All right. So now, before we get into changing the x and y values from the parent function, let's see what the new period is going to be for this function. All right. So I'm gonna draw the period. I'm gonna write. All right. So the period for this graph. All right. So remember, the formula for the period is we take 2 pi and divide it by b. So we have 2 pi divided by a half. So we have a radian divided by a fraction. So that's what I'm going to do the keep, change, flip technique. I keep this. I change the division to a multiplication, and I flip this fraction into 2 over 1, which is still 2. So 2 pi times 2 becomes 4 pi. So that means that the period for this function is going to be at 4 pi. So, which means that after 4 pi, that's when the graph starts to repeat. And if we acknowledge what 4 pi is in degrees, it would be 720 degrees. So it's kind of way far from 2 pi. All right. So we're going to see how that is going to affect the original graph. All right, so let's go ahead and change the x and y values. So for the first one, we have 0, 0. So I have 0, and then I multiply that by a 2, still end up with 0. And then I have 0, multiply that by 3, I still end up with 0. So I have 0, 0 for my first point. All right, so then I move on to my next point, which is pi over 2, 1. So I have pi over 2. So let me draw the here. So this is pi over 2, 1. So pi over 2, multiply that by 2. That's going to become, so pi over 2 times 2 becomes 2 pi over 2. And then I can simplify the 2's. That's just going to become a pi. All right. And then I have 1 times 3. I end up with a 3. So now my new point is pi, 3. So pi up 3. So we definitely, for the new graph, went from 0 all the way to pi. And we basically skipped most of the radians in between those two. In between those two whole radians. All right, so now let's move on to pi, 0. All right, so we have pi times 2 equals 2 pi. All right, and then we have 0 times 3, which becomes, still 0. So I have 2 pi, 0. All right. So now for my third point, I'm at 0, 2, 5, and I didn't even get to finish the rest of the 2 points. And if we were to analyze the work, we see that the graph doesn't start to repeat up until 4 pi, which is way far ahead on the right. All right. So I'm going to stop graphing, but I am going to continue writing out the 5 coordinates for 3 times sine of 1/2 x for the new function. All right. So I have my next point is 3 pi over 2, -1. All right. So over here I have 3 pi over 2 times 2. All right. So that becomes, so if I multiply these two, that becomes 6 pi over 2, which simplifies as 3 pi. So I have 3 pi, -1 times 3 gives me -3. All right. So now I'm almost done. Just my one more point. We have 2 pi, 0. So we have 2 pi, multiply that by 2. That becomes 4 pi, which is also the period of this graph. And then I have 4 pi. Then I have 0 times 3. That still becomes 0. All right. So I'm going to connect the 3 points that we only have. So this would be part of the graph for this function. Because remember, the period is at 4 pi, which is way further ahead. All right. So if we take a look, we kind of have this part of the graph for for 3 times sine of 1/2 x. All right. So in this situation, we see that the width and the height increased by a lot. All right. So now we're going to take a look at one more example. So for example 5, we have y equals to negative 2 times sine of x. So with this one, we only have a number in front of the trig function, which is negative 2. So luckily, we don't have both the amplitude and the period. We just have the amplitude. So that means that the amplitude, all right? So if we take a look at the amplitude, we see that inside A is an absolute value. Since an amplitude, we're measuring it, it's actually going to be a measurement. So we can't have -2 units. That's not possible. So for my amplitude, just go ahead and write it down over here. So for my amplitude, just going to write it as amp, is going to be the absolute value of -2, which is 2. All right? And then for my period, the period for the graph is we have 2 pi divided by b. All right, there's no b over here, so that means that the period doesn't really change, so it stays as 2 pi. All right, so we're only going to see a change of the height. Now we have the sine of x is being multiplied by a -2. So not only is the height going to increase, but if we take a look at the negative, it's also going to flip the graph. It's going to reflect over the x-axis. All right, so let's see how that changes. So I'm going to take my y, but I'm going to multiply it by -2. All right, my x's stay the same. So I have 0, 0. 0 times -2 is still 0. So, all right. Then we have pi over 2, 1. So 1 times -2 is now -2. So now the graph is going to be reflected. So from here down here. All right. And then I have pi. I'm going to go ahead and draw lines. So I have pi, and then 0 times -2, which is still 0. So I'm at pi, 0. And then we have 3 pi over 2, -1. So if I were to multiply it by -2, it would be reflected up here. All right. So if I were to actually do the math, so I have 3 pi over 2, then I have -1 multiplied by -2, it now becomes a +2. All right, so one more point. So now we have 2 pi. So 2 pi, 0. We have 0 times -2, still becomes a 0. All right, so I'm going to connect the points for the red dots. Let's go ahead, and we see that if we see that the graph increased in height and also reflected. All right. So in each example, we witnessed how the width and the height of the graph transformed based on having a number in front of the trig function and a number in front of x. So kind of like two coefficients in its own space. All right. So if you guys still have any questions, feel free to email me. Have a wonderful day.